if you go online, you see a lot of periodic table. If you search for a lot of periodic tables online, you see um, most of them having different structures, like the one that we've seen so far. The one where the D elements are removed. There's one where only the main elements are grouped together, and there's one special one that you'll be looking at. Then there's one special um, observation that you will make. There will be periodic table that is having this form, right? The form where they now put the hydrogen somewhere hanging in the air, But there are other one that we've seen so far where we see, for example, the one we're using mostly, you see that the hydrogen is attached to the period group 1 and all that, right? Yeah, there are other ones that we also looked at in the past. So let me see. Yes, I just want to illustrate something. The hydrogen atom was a member of the group 1. But then what about this one? Why is hydrogen hanging in the air mostly? So this is how, like, you will be able to see. This is how you should be able to see all the periodic tables. Most periodic tables will be the ones, if you have cubes, at the back of cubes, to be seeing the hydrogen hanging in the air. Why is that? Why is it hydrogen? Is it that they don't hate hydrogen, or hydrogen doesn't belong to any group at all? The idea is not really that the hydrogen doesn't belong to any group at all, but because of one character, one mystery about the hydrogen. We say the hydrogen is the very first element on the periodic table, and if it's the very first element, then it has only one proton. Elements on the periodic table are grouped in increasing number of protons from left to right all the time. So if we go back to this, you see you have to count from left to right. You have to go in this direction, and then you'll be increasing in proton number by 1. So hydrogen is the first one, so it's 1. If you go to the next, it's 2. If you go, then you come back, because that line is finished. You have to come to the next line. 3, 4, 5, 6, 7, 8, up to 10. Then you come again. You count like that. You see the numbers. The things are even numbered over there, right? And that's the proton number. So the position tells you the proton number at that point. So position 1 is for proton number 1 in hydrogen, and the hydrogen is basically over there, right? But it's having only one. Then why, if it's the first one, why should we treat it? Is it like it's the king of the periodic table? No, let's understand that mystery. So if I want to draw the periodic table, the hydrogen atom, sorry, let me say the protons are here. So the very first one there is not like anything, it's not a shell, but like that's the nucleus, and around the nucleus, you see hydrogen has only one electron or one proton, right? If it has one proton, then the same number of electrons will be the same, because it's hydrogen atom. We are going to look at the hydrogen atom especially. So for that, I'm going to add only one electron here, and the inside here is inside the nucleus. There is only one proton. There's only one proton inside of the nucleus. So yeah, this is the nucleus. Let me write that. This is the nucleus, and this is the shell. So let me write, this is a K shell actually. This is a K shell actually. Yeah. So and this is electron. This is how the hydrogen atom looks like, the structure. But you know that the K shell, for it to be stable, the K shell, we say that it has to have a maximum of 2 electrons, right? It needs to have a maximum of 2 electrons before it can be stable, because the K shell all the things follow the formula 2n squared, and then the n in the case of the K is 1, which is squared, which is going to be at 2. So we need a maximum of 2 electrons for the K shell to be stable, and hydrogen has only the K shell, and on that K shell it has 1 electron. So that doesn't make it stable. Okay, then how does it bond? Right? Every particular species want to attain stability. Why do we give it to group 1? We say group 1 elements are metals, right? And metals give out electrons. So if hydrogen is in group 1, then you should be able to give out that electron, right? So you have only 1 electron. If you give her that electron, meaning that after giving her the electron and you are part of group 1, so if you are part of group 1, you should be able to, you are a metal, you are considered a metal, and you should be delivering electron. So if hydrogen is part of group 1, then it should be able to give 1 electron. If it's giving another electron, then hydrogen doesn't have electron again. So how does that come in? So if the hydrogen gives out the electron, right, you have the hydrogen here, and if you do minus electron, so if you are giving out electron, then the charge become H plus, right? Become the H plus. So how the structure look like? The structure will just look like this, the nucleus, right? Yeah, and the charge is from the nucleus because only proton is there. So the shell that's supposed to be here has lost its electron, so it's as if it's not even there. So you just have the nucleus. That's what happens to hydrogen when it's there. That's one way of becoming stable. That's one way of becoming stable on its own, right? The other one is that it can also to attain stability. To attain stability, the other thing that can happen is that because we need a maximum of 2 electrons, why can hydrogen just be part of another group, that takes 1 electron, and those group of elements that seek for 1 electron are in group 7? Because we look at that already, that group 7 elements, they have 7 electrons or 7 valence electrons on their valence shell. So to attain stability, to attain 8, they need to take 1 electron in excess. So all group 7 elements are like that, and hydrogen is having 1 electron on this shell, right? And then to attain stability, it can decide to actually go for another electron, 1 electron, to have 2 electrons on the K shell, and that's going to attain stability. So the other way is that then hydrogen can be part of the group 7 element who generally takes in 1 electron. They are the guys that seek 1 electron. If you are part of group 1, then you should be able to deliver your electron. If you are part of group 7, then you should be able to seek 1 electron. So for hydrogen to become stable, to become fully stable, what will happen is that they will have the hydrogen, right? They will have this hydrogen taking another electron, then it will become something like this. Yeah, become something like, so we have added 1 electron at that moment. Because we have added an electron, right, the hydrogen become H minus, right? So in this case where it is seeking an electron, the hydrogen is going to act like a member of group 7, but in the case where it is delivering an electron, right, it's going to act as a member of group 1. So that's the reason why we put hydrogen in the middle, because it belongs to either group 1 based on what's happening, whether it's giving out electrons or it's taking. If it's giving out electrons, then it's part of group 1, but if it is seeking electrons, it's part of group 7. So we put the hydrogen actually in the middle, right, with that knowledge that it can do either give out the electron or take 1 electron. That's why hydrogen is actually hanging in the air like that. Not that it's part of all the groups, but then mostly because it have 1 electron, we put it in group 1, because mostly all the group 1 elements have one electron on their valence shell, and the valence shell for the hydrogen atom is its own K shell, the only shell that it has. So that's why we just put it in group 1. But generally, it's based on the behavior at some point in some chemical reactions. You see hydrogen being part of group 1, that's when it's ready to give us electrons, or be part of group 7, acting like group 7 when it's now taking electron. So an example of that is you'll be seeing it in sodium hydride. So in the sodium hydride, right? No, so hydrogen is meeting sodium. Sodium is in group what? Group 1. So at this moment, sodium gives us electron. That one, sodium doesn't have the choice to either take electron or give electron. It has the only focus on giving out electron. And hydrogen has both behavior, right? So when sodium wants to give, right, the hydrogen will be at the other end to take. So at this moment, in this particular species, hydrogen is acting like a taker, and the sodium is always a giver. All group 1 elements are always givers. So sodium is giving 1 electron, and this guy is taking them. We are going to look at other species, right? We are going to look at other species, and in part of those species, you will see like acids. But we have HNO3 minus, right, coming with hydrogen plus. These guys come together to form the HNO3. Right, we'll talk about this naming and all that or later, but then we have to get the understanding that in this moment, hydrogen is now acting like a giver to this particular species, then to form HNO3. species, right? That's how hydrogen has a both behavior, and for that reason we have to put it at this position on the periodic table. So if you see on the periodic table, now you have the knowledge and know why it's doing that. It's because hydrogen has two characters. Let's meet in the next session and see and continue building on these concepts.